Question 3 here has 3 parts, and all 3 are related to absolute values. We've talked a little bit about absolute values, and what we had noticed is that the absolute value itself will always result in a positive output. However, when you try and cancel some absolute value expression with something that does not have an absolute value, you should be worried about the signs, right? Because, like we said, if the absolute value cannot give you a negative number out of it, but the other expression that's not absolute value does have a negative, their cancellation would result in that negative staying there, right? So if, let's say the absolute value gave you outcome of 3, but the term that looked just like that without the absolute value gave you negative 3, they cancel, but you get a negative 1, right? The 3 and the negative 3, the magnitude 3 goes away, but the sign negative to positive stays. That's what we're worried about here, okay? So as we go through, I'm going to talk about the cancellations that would have occurred, but in our head, we need to remember, and we can actually write this out by hand if we want to, we need to remember that there might be a sign change that is still going to exist, okay? So let's start with A here. I take the limit as x goes to 1 of the numerator x squared minus 1 divided by denominator absolute value x minus 1. And what I notice is that, okay, well, as I plug in 1, I guess clearly here, 1 minus 1 would be 0. 1 minus 1 would go to 0. This is an indeterminate form. I'm going to have to do some more work, right? So I take my limit. I go to 1, right? Limit x goes to 1. And I notice in the numerator is a difference of squares. I can go ahead and factor that. X plus 1, x minus 1. In the denominator, I still have absolute value x minus 1, okay? So what I noticed that here, I want to cancel these, right? I want to cancel x minus 1 and absolute value x minus 1, but I need to be very careful because, like I said, if I cancel and this term has a negative sign, this one is always a positive, I'm going to lose the negative sign when I just go like this and I ignore that aspect, right? So what I'm going to notice is if I try and do this cancellation, I'm going to focus on both sides, right? I'm going to focus on as I go 1 to the left, right, from the left, I'm going to focus on the left side. And then I'm going to do the same with the right. So here I'll take the limit as x goes to 1 from the left side. And what we notice is that if I do this from the left side, taking a number 1 from the left would be a number slightly less than 1, something like 0.999 repeated, right? A number that's just a little bit less than 1. If I were to cancel out this with this, well, the top one would have given me a number that's, or sorry, at the bottom would have given me a number that's a little bit positive, right? But the top would have been number less than 1 minus 1. That would be a negative number, right? 0.99999 repeated minus 1 would be 0.00001. That's negative. So what this means is that there is going to be a negative sign that's going to have to maintain in this problem if I were to just cancel these out, right? I can cancel them, but I need to remember that by plugging in the 1 from the left, this would have produced a negative. So theoretically, I can cancel them, but I have to attribute a negative to the problem to account for that aspect, right? So what I see is that this is really the limit as I go towards 1 from the left of negative x plus 1. And if I go to 1, I plug it in. 1 plus 1 would be 2. With the negative, I get negative 2. Okay? So from the left side, my limit's going to 2. Not too bad. If I try it from the right side, same deal, right? X plus 1, x minus 1 over absolute value x minus 1. In this case, since I'm going 1 from the right side, this number would be positive, right? Think about 1.000 repeated 1 minus 1. The left side number is slightly bigger, right? This is just a little bit bigger than 1. This is a positive outcome. And the bottom would always be a positive outcome because it's an absolute value. So these can cancel, and I don't need to worry about a sign because they're both positive. The outcome would be still just a positive 1. So now I'm taking the limit as I go to 1 from the right side of just x plus 1. You plug in 1, 1 plus 1 is 2. Well, what do I notice? these two are not the same, right? The left side goes to -2, the right side goes to +2. Therefore, this limit, as we go to 1 itself, right, two-sided, of x squared minus 1 over absolute value x minus 1 does not exist, okay? Or limit does not exist here because our two sides are not corroborating, right? They're not going to be equal. Sweet, easy enough. Let's keep going, right? We're dealing with absolute values. Part B of this question, we have the limit as x goes to -2 of this here. And again, let's just go ahead and plug in. So if I plug in -2, I get 1 over -2 plus 2, which is 0. But remember, it's absolute valued, right? So sure, I might want to consider -2 from the left and -2 from the right, but because it's an absolute value, whether I get 0 from the left or 0 from the right by plugging in -2 from either side, it won't matter, right? Because the absolute value is going to make that positive no matter what. So I can do this kind of in one big swoop, and I can just say this is 0 from the positive direction, right? And then plugging in -2 squared would just produce a +4. Well, recall the outcome of this. This, a number over 0, would push to infinity. Since I already have the signs, 1 is positive and 0 from the right side would be positive. This would push me towards positive infinity. And then me adding 4 to something that's already going to positive infinity is just going to stay at positive infinity. So my limit for that one is just going to be positive infinity. A little bit more straightforward, right? And we were able to use that absolute value here to our advantage, yeah? So we didn't have to check both sides. We knew that actually both sides would be the same because of the absolute value here, okay? Note that there's no cancellation that occurred like part A. Part A, since there was a cancellation, that was kind of one of the big deals where we had to check both sides, right? That's kind of why we did that. Now, that's our A and B. Let's look at C. So C, again, we notice there's some cancellation happening here. This is going to be similar to then question A, right? Where this and this might go away. Do I need to make sure that there is an added negative sign or something like that here? Well, let's look at where we're going towards. Here, we're going towards 3 from the left side, which means if I go 3 from the left, when you plug in a number that's less than 3, this expression on the inside would have been a negative, right? Going closer to 0, but from the left side. But when I absolute value it, it would have been positive, right? 0 from the right side. The bottom would be 0 from the left though, right? So a number a little bit less than 3 minus 3, you'd get a slightly bit negative number conceptually. And so what I notice is that I'll have to add in our negative sign, right? If I want to go ahead and cancel these out, I'll just go ahead and add a negative because I know that the ratio would be positive to negative based on coming from the left. So all I got to do is take my limit as x approaches 3 from the left of -x squared. And what does that give us? Well, we get 3 plugged in for x squared, 9, with a negative outside. We get -9. Therefore, my limit on that one is going to be -9. Okay? So hopefully we feel a little bit better about these absolute values now. Note that if we don't have any cancellations, the absolute value might not be a big worry for us, right? So such as in part B, we didn't have a huge worry because I wasn't canceling anything, so I didn't necessarily have to do an analysis on both sides. But for A and C, I certainly was canceling, and we saw that from one side or the other, we did have to add some negative sign in. So keep that in mind. This is our problem 7. Let's keep going.